we would like to open it up now for the Q&A. Again, please enter your questions in the Q&A box below. We have a few questions that have come in, so we can get started here. David or Mitch, what are the downsides of using this type of low offset op amps? David, you need to unmute. I'm sorry.
Yes, sorry. Can you hear me now?
Yes, we can hear you now.
Okay, yeah, sorry about that. Yes, so the downside of using this type of low offset op amps, one is obviously in terms of power consumption, it will consume higher than without this technology because of all the demodulation and modulation circuitry involved. And basically, if you look into detail, that is basically we're talking about like 3 extra amplifier plus the MOSFET switch to switch the input. So the immediate downside is both cost and higher power consumption. But sometimes in case where, because like something like to compensate for temperature, sometimes it's impossible to do in a system. So even though with those high costs, there's still many applications for which a low offset zero drift amplifier makes sense, because in many cases, pretty much it is the only choice. Yeah.
Okay. Thank you very much. Let's see, next question here. What is there to watch out for?
You want to take on that, Mitch?
With the zero drift op amps, you would want to make sure that your source impedance is reasonably low. 5,000 ohms or less would be ideal. And the supply voltage is limited to 5 volts. So you need to have an application where a 5 volts gives you an adequate output swing.
Can I? Yeah, so I'd like to add something to that. So as Mitch mentioned, we like to make, it would be good to have a low source resistance, and the reason because during the switching operation, the chopper circuit basically generate a transient current at the switching at the chopping switching frequency, and that causes transient on the current, and that current flow through both the feedback resistance and the source resistance, and that's why Mitch was mentioning. That's why we like to you would like to keep it low. Yeah.
Thank you. Okay, next question came in is, what is the calibration or mode-demode frequency? Mod-demode frequency, sorry.
Okay, I guess the question probably meant to ask about the chopping frequency. So if that is the case, the chopping frequency is 300 kilohertz. It is a little bit higher than you normally see. We've seen like people do like 40, 50, for example. So the chopping frequency does not mean like the input frequency is limited to that or below, because sometimes we have questions about that as well. So the chopping frequency does not impose an upper limit on the input frequency of the signal. That frequency is actually limited by the gain bandwidth, which in this case is 1.5 megahertz. So depending on your gain, and that product is got to be below 1.5. But the switching frequency being at 300 kilohertz, the only, at least related to the downside question earlier, that only means like at 300 kilohertz and its harmonics, there will be current transient. Whether that causes a problem or not, that obviously depends on the application. But in most cases, we've seen that a simple RC filter in case that is an issue, is enough to suppress the noise. But if you keep the source resistance low as Amit recommended earlier, then that shouldn't be even an issue in most cases. Yeah.
Great, thank you. Another question that came in. Does this come in a smaller package?
Yes. The part number LMR 1001YG-C comes in the SSOP5 package, which is 2.9 by 2.8 millimeters.
Okay, thank you so much. Just waiting on, we have some more questions coming in here. Again, if you have any questions, please drop them in the Q&A box. All right, we have one more come in here. When do you use this type of op amp?
Okay. Well, to think a little bit, it's a fairly broad question. So obviously, in general, it is low offset, zero drift. So the offset, if we go back to the basic, the offset basically cause an output error voltage which is proportional to the non-inverting gain, right? So obviously, the bigger the offset, the bigger the voltage. So in case you want high precision sensing and you need high gain, and in that case, obviously a low offset would be a good place for that. And the other one is, in addition to low offset, because the action of chopping, whether the supplier does, like in our case, we do chopping, but others do like auto steering. In both instances, that action also reduces the noise as well. So not only reduce the error output due to the offset voltage, it also reduces the noise. So that is another area where low offset zero drift have a good application. And the last one I think I'd like to mention is zero drift. So you look at the drift over temperature and over the lifetime or aging drift, that number is pretty low, extremely low, sometimes very close to zero. So if really you think of application where it requires high operating temperature, or those that has very long lifetime, like automotive or utility meter, like smart meter, electricity meter, gas meter, over the lifetime, that drift and the op amp wouldn't behave according to the initial spec anymore. So in all of those cases, the zero drift, and by implication, that means zero or almost zero temperature and aging drift are very low. So those products with long lifetime or wide operating temperature range would be a good application for this type of op amps.
Okay, great. Thank you, David. We have another question come in. What kind of speeds can this op amp work? At what speeds can this op amp work?
Yeah, so the gain bandwidth product for this part is 1.5 megahertz. So that represents the frequency at which the gain drops to 1. So, for example, at a gain of 10, you could have a bandwidth of 150 kilohertz, and so on. So as long as the gain bandwidth product came out to 1.5 megahertz, it's usable.
Yeah. And in case you have a question about, in case you mean like the slew rate, when you mean speed, then the slew rate, I think we note somewhere in the data sheet is about 1.3 volt per microsecond. Yeah.
Okay. Are there any more questions? All right. Okay. Thank you very much. David, do you have any? final words or additional information?
Yeah, so just want to add, so regarding the speed, so obviously this op-amp is good enough to act as to amplify signal from sensor pressure, like in industrial process control or pressure or temperature sensor, obviously, but it is also fast enough to measure like in current sensing as well. So I think even if say you don't care about, let's say you don't want to put a filter to suppress the harmonics at the chopping frequency, then 300 kilohertz for most applications would be good enough for current sensing. It's good enough to measure the transient current as well. Yeah.
Okay. Well, thank you, everyone. The presentation will be available on demand. And thank you for joining us, and we hope you'll join us again for future webinars.
Yeah, thank you, everyone. And may I ask one last thing? So we actually didn't have our email here, but if you have questions, please feel free to email, give us a call. We'll send out our contacts later after the call. Yeah.
Thank you, David.
Yeah.